Hello everyone and welcome. In this video we are going to talk about basic electronics and how electricity behave in a circuit. Then we will introduce a variety of components that we use in our circuit, examine how they behave in a circuit and how they can be useful to us. And at the end we will talk about three important rules that in electronic engineering always help us to make a better circuit and design a more reasonable and useful circuit when we are trying to make something. First up, we are going to talk about power supplies or power sources. The most simple way that we can describe a power source is to consider a battery. We have all used batteries before and we already have one battery in our smartphones that we use every day. Power sources usually come in two different types. One is DC and one is AC. Now we are going to learn about the difference between DC and AC power supplies. If we connect our DC and AC power supplies to an oscilloscope, we will see something like this. For DC power, it's always constant like a line, but for AC powers, it usually changes polarity over a certain amount of time. A common example of AC power is our mains electrical grid that we connect everything to it. It usually looks something like this that we call sinusoidal wave, and it's usually around 50 or 60 Hz, which means it changes its polarity 100 or 120 times every minute. The first step of understanding basic electronics is to know how current flows through a circuit. In this case, we have DC power and AC power shown in the video. For DC power, current always flows from the positive side to the negative side. And this is a set rule. We consider it like this. Electricity always flows from positive side to negative side on DC power supply. But what about AC power supply? Well, it gets a little bit more complicated. As we said before, AC power changes its polarity over time, and this changing polarity over time means that the flow of electricity changes direction with that changing polarity. For example, if we consider the upper side of our waveform, we can see that the positive side is on the upper side, and again electricity flow from positive side to negative side. But if we consider the lower side of our waveform, electricity flow from the positive side, which this time is the lower side of our circuit, and goes to the negative side. As you can see, the direction of flow of electricity has been changed, and the current in our circuit is changing its direction with our waveform. Next step, we are going to talk about components, and while we are talking about components, we are going to use DC power for easier understanding of what's going to happen in our circuit with every component. So we consider the DC power and we add one component and examine the behavior of that component in our circuit. For first component, we use a resistor. What happens if we connect a resistor to a DC power source? The current starts flowing from the positive side, goes through the resistor, and goes back to the negative side of our circuit. Some of the energy that we put in the circuit will be lost in our resistor. What's going to happen to that energy that gets lost? It's going to change its form from electrical energy to heat. This is a really useful example of our heating elements. Another thing that a resistor can do in our circuit is to limit the amount of current that is passing through that resistor. This is another useful example of using resistors, which is more common in electrical circuits. Next, we have capacitors. When we connect a capacitor to a power source, doesn't matter if it's AC or DC, it's going to charge up and store the electrical energy. But it's not as powerful as a power source or as a battery. It's more limited. Capacitors also can be used as delay in our circuits. When they are charging up, it takes a certain amount of time to charge up, and we can use that certain amount of time that we used for charging our capacitors as a delay in our circuits, which is a common use in analog circuit. Next up, we got inductors. Just like capacitors and batteries, inductors store electrical energy, but they store it in a form of magnetic field, which has a few advantages and disadvantages. For example, when we charge a battery, it can hold its charge for days without going empty, but an inductor loses all of its energy as soon as they get disconnected from a power source. The amount of energy that got stored in the magnetic field will collapse immediately and it loses all of its energy suddenly. Inductors also can be used as filters. They can allow certain frequencies to pass and block some of them, so they can be used as filters too. Next, we got transformers. Transformers are usually a kind of inductors that instead of one winding, they have two or multiple windings. They can store or transfer electrical energy. They can store it in a form of magnetic field or transfer it as electrical energy between windings. Because transformers can transfer energy from one coil to another coil, they can also be used to change the voltage ratio between windings by just changing the windings ratio. This is a really useful trick to convert higher voltages to lower voltages or lower voltages to higher voltage whenever it's needed. Next up, we got diodes. Diodes usually have two pins, anode and cathode. Diodes allow electricity to flow from anode to cathode. In this case, they can allow electricity to flow between positive side of the circuit to the negative side. Because the current starts at the positive side of our circuit, goes through our diode and goes back to the negative side of our DC power source. But if we reverse our diode, because the cathode side is at the positive side of our power source, it will not allow electricity to flow through this circuit. So diodes control the direction of electrical flow in our circuit. And because they can control the direction of electrical flow, they can also be used to control signal path in our circuit. Next up, we got LEDs or light emitting diodes. These are fascinating components that if we pass electricity through them, they will light up and transfer and convert the electrical energy into photons or light source. The next component is so simple but so useful in our circuit: switches. When we open a switch, we break the circuit and the flow of electricity through that circuit will immediately stop. And when we close the switch, the electricity flow through that circuit and the circuit gets complete. Very useful devices that we use almost in our daily lives. They are so simple but still so useful to us. For example, if we consider a light bulb, with a click we can complete or break a circuit, and that's how we turn off or turn on a light bulb in our houses. From now on, we are going to talk about some devices that act like a switch in our circuit. One of them is a transistor. Transistors act like a controllable switch that we can control them with electricity, or in this case, because the amount of current that we need for this control pin is so low, we can call it a signal. Just like our switches, we can turn on and turn off our transistors. In our switches, it's usually a form of mechanical switch that we operate with our hands, but for transistors, this is kind of different. We need to apply a certain amount of voltage to the signal pin, which is usually called base, to close or open that transistor, or more commonly known as turning on or turning off that transistor. We have another device that acts like a transistor but has a few important differences. We call them MOSFETs, and they behave like transistors. They have a gate pin that if we apply a signal to that gate pin, we will turn on or turn off that MOSFET. But there is an important difference between a MOSFET and transistor. The important difference is that a MOSFET gate is insulated from the rest of it. Therefore, there will be no current passing through the gate to the source of our MOSFET, which is really useful for high voltage applications. Next up is a fuse. When we connect a fuse to our circuit, they are usually there to protect the circuit from getting any damage or excessive amount of current passing through that circuit. Fuses are really useful and we use them in almost everything in our life. We have fuses in our homes, we have fuses in our cars, we have fuses in our phones, we have fuses in our every electrical device that we operate. They are cheap and they can prevent a lot of damage. So when something goes wrong, instead of paying a huge amount of money for replacing something, you can easily fix it and replace that fuse and get it working again. Next up, we got two components that are really useful and you should know about them, but they are not meant for DC power sources. First, we got the speakers, and then we got crystal oscillators. We connect the speaker to a DC power supply, it's just gonna make a really faint humming noise and it's not gonna be useful to us. They are really meant for AC signals, and we use crystal oscillators to get an exact frequency that we need. So now we know some of our components and we are familiar with them. We know how they act in a circuit, we know how electricity behave in a circuit, and if you keep this information in mind, in future if you are making a circuit or repairing something, just by remembering these simple things, you can analyze any complicated circuit based on this simple knowledge and use it in your advantage for your future project. Now that we know how electricity works, we have three important rules that if we keep them in mind, we are going to be a better engineer and make better designs. First rule is the conservation of energy. What is it saying? It says that energy can't be destroyed or created, it just can change form from one to another. For example, with resistors, electrical energy got converted to heat. It didn't disappear, just changed its form. So if we are making a circuit, we should keep this in mind, that electrical energy doesn't get created or destroyed. We just take it from another form of energy that we don't need and change it to something that's more useful for us. Second rule is the Ohm's law. What is it saying? It basically says that voltage is equal to amount of current multiplied by resistance. For example, if we go back to our DC power source with the resistor, consider a voltage for a power source and a resistance for a resistor. We can put it in this formula and see how much current is going to pass through our circuit. Next up is the electrical power. Electrical power is usually equal to amount of voltage multiplied by the amount of current that is in our circuit. There is another form that we can write down this equation, which is sometimes more useful. If we merge the previous formula with this formula, we will get this formula, which indicates power is equal current squared multiplied by resistance. So if we go back to our example, we know the voltage, we know the current, we know the resistance. There we can put it in this formula and see how much power is used in our circuit. So these are the basic electronic information that, in my opinion, you can use in your circuit designs and can be useful for you in your future projects. If this video was useful for you, please hit the like button. If you'd like to watch more videos on this channel, don't forget to subscribe. And if you have any questions for me to answer, please leave them in the comment section and I will answer all of them. Thank you for your attention and for your time.